Hey everyone, welcome to this final part of the Azure Masterclass, part 11, Infrastructure as Code and DevOps. So the whole goal of this module is to walk through some of the ways we can interact with Azure, both through graphical interfaces, through command lines, and infrastructure as code. Look at ways we can help manage when we have these various elements, these artifacts like maybe scripts, maybe JSON files, whatever it might be, using Git and that whole version control solution. And then what is DevOps and how does it fit into this whole picture? So I want to start off looking at the portal, looking at PowerShell, looking at the CLI, just to understand, well, where do they fit in the picture? Because for most of us, when we start out using Azure, the portal is the first place we're going to go. And so why are we bothering when we have these great options with infrastructure as code, which sounds really complex? So why would we ever do that? Because we do have these great options. Now I'm going to say we have these great options to create resources, but as we'll see, maybe they're not as great as we think they are. So we obviously have the portal, and we're going to walk through all of these quickly. So the portal is fantastic in terms of it being very intuitive. So if I was to just quickly jump over, for example, the portal, hey, I don't really have to know a lot about what I want to do, but I could say, well, I know I want to create a VM. So I could do create a resource, and straight away, for example, hey, you want to create a VM? Okay, but let's create something even simpler. And maybe I've got my little shortcuts down the side, which is really easy. I have my favorites. I can go to my all services. And under all services, it will just show me everything. And I can always click this little star. That will make it a favorite. So then it will show by default under favorites on that left navigation bar. But I can always just jump to all services to see everything that's possibly available to me. And also we typically start in home, but I can also create dashboards. And we looked at dashboards when we looked at the idea of monitoring. But let's say something even simpler. Let's take a storage account. So the good old storage account. I say, hey, I'm going to create it from the portal. Okay. Well, there's some things to fill in, some choices. Not too bad. Okay, but wait, now there's some other choices I need to make. Not quite sure which ones I should do. Then there's some networking. Okay, data protection, encryption. So even for the basic storage account, there's a whole bunch of different options that I have to pick. Now think about doing that in a consistent way, and now thinking doing that at a large scale. I had to create 10 storage accounts. How horrible would that experience be? Now what the portal is fantastic for is, well, it's very intuitive. If I don't know what the options are, I could look at the portal. I could look at some of the options it gave. If I'm trying to understand what's happening with a resource, well, this is great to go and, hey, I can select a resource. I could go and, for example, look at some basic monitoring data around it. I might have insights, so I can get deeper insight into exactly what's happening, maybe mapping to see what it's communicating to based on network communications. I could maybe go and look at what's changed about this resource recently. Obviously, it's fantastic for looking at monitoring overall. So the portal is fantastic. It's very intuitive. However, I would not be really trying to do any actions en masse with it. It's just not scalable. So if I start to think about, well, what are my options? So if we draw our Azure cloud, that's not the right color. What is going on here? Let's start again. Blue pen. There we go. We have to have the right color. It just doesn't work. So if this was Azure, and then if I think about, I'm over here at my machine, and we're going to see there's a whole bunch of different ways that I can interact. Now, one thing in common, it doesn't matter which one of these different types of interactions I'm doing, all of them are going through the Azure control plane. So we talked about this before, but the Azure control plane is the Azure Resource Manager. And it doesn't matter what we do, we are going through this. So if from my machine, I'm accessing the portal, for example, So I'm connecting in and I'm clicking, clicking, clicking. And this is the whole point. It's very intuitive. It's very nice to go and look at. But the thing it isn't, it is not scalable. It's also in a lot of ways not consistent. Because how do I know I click the same options every time I use it? I don't have that assurance because it's a human. Anytime a human's doing something, even if there's a nice laid out document of do these steps, humans will still find a way to do it wrong. So it's not scalable, it's not consistent. Which if I think about environments and I'm pushing code through, I need to make sure everything is done the same way every time. But no matter what I do, this is going via the Azure Resource Manager. So the portal's nice. It's great to go and look around. It's great to go and see what's going on. It's great for monitoring, but it's not scalable. It's not consistent. So I would not want to create resources. And because it's mouse clicks, it's also not very good for automations. If I have some tasks I want to do over and over again, yes, there's ways in software that I can capture mouse clicks and key presses and replay it, but it's just not a good idea. What if they change the portal? What if they change around something? So that's probably not a great option. Then we have PowerShell with the AZ modules. Remember, PowerShell is cross-platform. I can run this on Windows. I can run this on Linux. It's free. And there's an Azure module. Well, it's like a super module. The Azure module consists of lots and lots of little modules around all the areas of functionality that's available to us. So the PowerShell with the AZ module is great. And then there's also the AZ CLI. Traditionally, that was thought of for Bash, for example, in a Linux world, but this is cross-platform as well. So both PowerShell with the AZ module, I can run on Windows and Linux. The AZ CLI, I can run on Windows and Linux. So both of them have the same benefits. But both of these are imperative. I'm telling it how to do the step. I'm describing the steps I need you to perform, which has some pros and cons, but it's really good when I think about automation. So that's the goal for this. There's also the Cloud Shell, but we'll come back to that. So if we think of our options again for a second, so we had the portal, sure. We then also have PowerShell. So we have our good old PowerShell, and we're installing the AZ module, which again is a meta module. It's going to actually import lots and lots of smaller modules. And we also have the AZ CLI. And the key point is for both of these, they are both cross-platform. So my Windows, my Linux, it's our platform as well. I can run with this. And for both of these, it's very common that I might want to use them from VS Code. VS Code provides a great environment that not only can I create the scripts using these, there are extensions that make it even easier, but I can actually execute the things from here as well. But the whole point of these modules is do this action. And then do this action, and then this action, etc., etc. So if I think about where this is really powerful, where I'd want to use this, it's automation. So if I have some tasks I need to do again and again, hey, it's a certain hour, I need to start the VMs. I need to stop the VMs. I need to, whatever that might be, PowerShell and AZ CLI are fantastic for when I have some automation I want to do. But the key point is I am telling it what to do. So these are imperative. And once again, as you would imagine, these are going via the Azure Resource Manager control plane. So it's fantastic for automation. It's still not very good for creating resources. Could I? Absolutely yes. And there are quick commands to easily create a VM, easily create any resource you can think of, including a storage account. But imagine I want to change that configuration. Because I'm describing what to do, Imagine my script failed halfway through. It can't just run the script again because a bunch of the commands will fail. Hey, create this storage account. Error, this account exists already. Okay. Now I need to use a different command to maybe go and check it's there. And if it's already got part of the way through the script, now I need to use a different command to modify. So it's a little bit ugly in terms of creating the resources, updating the resources. And it's also quite hard to tell if the resource that exists matches the script. I would have to go, okay, so we ran this command to do this, and then this other command to do this other thing. Okay, that looks correct. But because of that imperative nature, it's not always obvious to tell, is it matching the script or has it drifted, which is an important thing. We need to know if resources have drifted from our configuration, but it's hard to change them. It's going to be a different set of commands to change them than to initially create them. But let's have a little look at both of these. So if we were to jump over to, for example, VS Code. So I've got PowerShell installed. Now, when we think of PowerShell, we're not talking about, on the Windows side, Windows PowerShell, the version that came with it. We're thinking about it used to be PowerShell Core, but now if I look at my PS version table, we're talking about PowerShell 7, where it kind of collapsed the name Core, but it's still behind the scenes is this Core that it runs on Linux, it runs on Windows, but with PowerShell 7, they just called it PowerShell. So we want to be running PowerShell 7 or above, not Windows PowerShell. And then we just install modules. Now I'll see up here, I've already run a lot of these commands. So we just install the module AZ. Now what I've done is I've done a scope of all users and false. Now the scope all users means it's going to install it in a location that every user can use. It will be available for all of the users of the machine. And then I actually install some other modules, the resource graph and also the Microsoft graph. The Microsoft graph is now this standard way to interact with many of the APIs, including Azure Active Directory. I can check the version I have with this get-module AZ list available. And we can see I'm running 9.4, which I just updated this. That is the current version. Now you can always run update module. However, what I find with update module is it leaves the old version around. If I was to look at the file system, this is actually what gets installed. So when I installed the AZ module, it actually installs, well, there's an AZ.accounts, an AZ advisor, the list goes on and on and on. But inside any one of these, there's a particular version. And what can happen is when you just run AZ upgrade, it leaves the old one behind. It will get superseded, but it gets a little bit ugly. So I don't actually tend to do the upgrade. I will just delete all of the old modules. You can just select the folders, all of them, and delete them. And then I would just run the install again. So I would just run the initial commands. I'd never actually do update module. For some things it works fine, but for these meta type modules, it tends to not be the best option. And then once you've installed the AZ module, you have to authenticate to Azure AD. So for this, we use the connect AZ account command. And what that is going to do is it's going to just use a Explorer or any web page you have available to you, but it's going to use the auth code flow. So it will pop up a browser window and will say, hey, you're trying to authenticate with PowerShell. Did you mean to do this? You say yes. Then assuming you're logged into Azure AD in that browser, it will then authenticate you to this PowerShell session as well. And it uses a token that is long-lived and it will auto refresh. As long as I keep using PowerShell, I won't have to authenticate again. If I'm on a machine where I don't have a browser window available to me, then I can use something called device authentication. It will show me a code. I will go to a special page for that authentication, type in the code and authenticate. There's also ways I could pass it a username and a secret if it was a service principal. But if you're a resource in Azure, and we saw this before, I can use -identity. That will just use the managed identity available for whatever the resource is. So I don't have to have any secret, any certificate, anything at all. It's just going to authenticate me with the managed identity that's native to my resource. And then once I've authenticated, we have contexts. So if I look at my contexts, I have a whole bunch of different contexts available to me. But think of this, maybe my account has access to lots of different subscriptions. So I can rename these contexts. You see, I've renamed them to nice names, Savile Tech Dev, Lab, Production. You can then easily switch between them. It will save these between different sessions. So again, it's something that I have to go through once I authenticate, once I set up my context, but then I'm really done. I'm good to carry on. And then I'm just using PowerShell as I ever would. And the same types of things that exist for any PowerShell module. Hey, show me all the commands in the compute module. Okay, there's all these commands I could use. Show me all of the commands that use the new verb. So remember, there's always this idea of least cognitive distance between PowerShell. So it's always, hey, verb, noun, the action I want to do on the thing I want to do it on. So, hey, my verb is I want to create a new something. Well, okay, here are all the commands in the compute module that do a new on something. Will show me all the commands I can do on an AZ VM. So all of the different command nouns start with AZ. So this is, hey, AZ VM, so I can get an AZ VM, I can do a new AZ VM, I can remove an AZ VM, restart, set, start, etc. Or I can look at those. Okay, they're the VMs I've got there. So a demo Linux VM and a demo VM. Show me the status of these. Okay, I see one is deallocated. I can see one is running. And then I can just do everything else I can do with PowerShell. So I have the whole idea of the pipeline. I could now go and check, well, hey, show me only the ones that are not equal. So I've got the NE that are in a power state of not equal to running. So the ones that are stopped. And I could then maybe pipe that command to, hey, start them. So there's a whole bunch of different things I could then do. And I've got some other examples in the file. I'm not going to go through all of these. But you can see here it's very easy to get information about images that are available, to create new virtual machines, to even deploy templates. And then I have the same thing for the AZ CLI. I can just install the AZ CLI. There's different ways I can install it. Documentation goes through them. But again, the first thing I would do is AZ login once I've installed it. That will use that same authorization code flow. If I don't have a browser, hey, I can use the device code. Once again, I could use managed identity. We can see here. And once again, I could use a secret. I could use a certificate. So it's using the same authorization flows as PowerShell. One of the nice things, and PowerShell has this as well, is I can see the version. I just updated the version before I started recording, but it will actually let me do an upgrade. So I can run AZ upgrade, but it also has an auto update. So I can go here, if I do my config git, I can see somewhere. So auto upgrade, I've got set to enable. So I'm enabling the auto upgrade, and I've also set the prompt to no. So it's just going to automatically upgrade if it detects there is a new version the first time I try to run any AZ command. So I can enable that as well. And then after I've authenticated, again, I might have different subscriptions available to me. So I can look at all my different subscriptions I have. I can switch to a certain subscription using the AZ account set --s. I can see what my current one is. And then it's just like anything else. There's a whole bunch of commands. Hey, I can create resource groups. I can create virtual machines. I can list virtual machines. So AZ VM list. Got my refresh token. I have to re-authenticate again. So I should, at this point, I would run the AZ login. So actually, we could just do that, I suppose. And this is the experience you get. So AZ login, hey, I popped up your browser because it's using the authorization code flow. you're already authenticated in the browser, you have logged into Microsoft Azure. That was it. And so now because I've done that command, if we go back and we can run the AZ VM list again, and we're equal to VM running, well, now it dumped out the output for my current account, which is the same really as a context in the PowerShell world. But as you can see, I can run all these different fantastic commands. And so from an automation perspective, this is phenomenal. I would definitely want to leverage this. So I can think about, hey, if I want to automate something, both PowerShell and the AZ CLI is going to be a great fit. One is not really better than the other. I prefer PowerShell because I come more from that background as opposed to a Bash background. So for me, it's easier to integrate the AZ module and what it can do with my experience of creating scripts. But if I was more from a Bash background and I'm more used to Bash, well, then the AZ CLI would be a better fit for me. So it's not one can do things the other one can't do. It's more a case of what am I more familiar with and could better integrate with my everyday work. So fantastic for imperative for automating things. Now, another option we have is in Azure itself, there's something called Cloud Shell. And Cloud Shell exposes both of these options to me. I can do both PowerShell or I can do Bash-based. Now, it is still going via ARM. It's not bypassing because it's in Azure, but it will auto-authenticate with whoever I'm authenticated to as the portal. So it's a really nice way. If I'm just on a browser somewhere, I'm maybe not on my regular machine, and I quickly need to type some commands, well then, this is fantastic for that. So if I jump back over to the portal in this example, and there is actually a dedicated Cloud Shell. I can go to shell.azure.com as well. But if I'm just in my regular window, it doesn't matter where I am, notice up here, there's this little prompt. That is Cloud Shell. Now, the first time you run it, you get this. It's saying, hey, you don't have any storage mounted. So it uses storage to store things like a profile. There might be certain artifacts I want to use. I can show advanced settings and I could set the storage account it's going to use. It's going to be Azure files. So I could go and actually specify everything I want to do. Or I could just hide that and say, just create it for me. I don't even care. Go and create me a storage account. Go and create me an Azure file share that you can use to store the artifacts I need for Azure files. So it's whatever you need to do. Once it's done and created this, I will then get the options for PowerShell or Bash. So I can switch between them at any time, but it will automatically be authenticated for me. So here you can see it's using PowerShell, but I could also switch at any time to Bash. So I can jump between them, but it's going to be automatically authenticated as me. And then I can just run commands. And it has all of those modules kept up to date for me automatically. I don't have to worry about that. So anything that is Azure centric, it's already going to have all of that available. So here we go, I'm authenticated to Azure. I'm auto logged in. So if I do my get AZ VMs, for example, there they are. I don't have to do anything else. If I do my get PS provider, we can see it actually adds a drive called ships. So we can see the name is ships, but this is actually a way to expose Azure and its configuration as if it was a file system. So let me go and look around at the different things available, my resources, without maybe even having to know all of the different commands that I might need to use. Within here, I do have access to code. So if I was to run code, it's showing me, basically it's based on Monaco. It's like a scaled down VS Code, but I have this ability to bring up a window here as well. So I could modify files, but hey, it's just a really nice environment to quickly do things. And again, I could switch to Bash as well, which will now go and spin me up a different environment. And all of these are actually running in a container that it's creating and then attaches to that storage. I don't know if this will actually work. This probably will not work in this one. I should have done this in the other command. Yeah, let me switch back a sec. Just you can see just what's interesting about how it manages and creates this environment. So if we jump back over, if I run PS version table, remember this is PowerShell. It's actually running it on a Linux container. So it's installed the PowerShell in a container based on Linux. So we can see it really is that cross-platform. And of course, I can just close this at any time I want. So that Cloud Shell is really nice when I just need some environment really quickly to go and run some sets of commands. So they're all imperative, they're all cross-platform, but again, it's hard to check what is deployed. If I have some script, how do I know what's existing in the world actually matches that script? I would have to go line by line. What does this line do? What does this line do? To actually understand and compare. The portal's not scalable, but those CLIs are fantastic for automation. So they have a great use case. It's just it's not for provisioning. So for the creation of resources, hey, I really don't want to be using those. Now, just from a slide perspective, and we went through all of this already, so obviously with PowerShell, I have to install the module. It's not native except for the Cloud Shell. How we can upgrade the module, we went through all of that. How I would do that authentication. So we had those different options we saw where, hey, I can use the authorization flow, where it pops up the browser, and we saw that. That would be the same for PowerShell or the AZ CLI. We could use the device code flow. Hey, maybe I don't have a browser locally on the same environment that I'm running the PowerShell or the AZ CLI. So it'll print out a little code, and then I would type that in on the other machine that does have a browser window. Or I could pass it a username and a secret. Or I can do identity to use the managed identity of the resource, providing, hey, it's running in Azure. We talked about the context and how I can have those different environments. And then with the AZ CLI, once again, it's really the same sets of actions. I download and install the AZ CLI. We have the upgrade options. It can auto upgrade. I could just run a new version of the CLI. We authenticate. We have the same options, the authorization code flow, the device code flow. I could give it a username secret. I can use a managed identity. And wherever we can, use the managed identity, both for PowerShell and the AZ CLI. Like a great way to run these, I could run these with Azure Automation. Even better for me, I'd like to run them as an Azure function. So Azure function supports PowerShell. I would give the Azure function a managed identity. And what's great about the Azure functions, as part of its default configuration, it will automatically use a managed identity to authenticate you if there is a managed identity for that Azure function. I don't have to do anything. I can just start writing my code, and it will automatically use the managed identity if there is one for that Azure function. And obviously, there's various ways we can then use the CLI, and we saw all of those. And before we go any further, I wanted to talk about the Azure Resource Graph. Because Azure services, well, we have that Azure Resource Manager control plane, and then there's actually resource providers. Now, everything in Azure is built on top of this. Now, we can query via the Azure Resource Manager. Sometimes the Azure Resource Manager has enough. So sometimes it has certain metadata. I run some type of query. It knows everything it needs to know. Sometimes it doesn't. Sometimes certain queries I run, well, there's a whole bunch of resource providers. So there's an architecture that I have resource providers, and we saw those in the modules. All those different modules are there for each specific resource provider. So I might have the compute resource provider. Well, the compute resource provider defines what is a VM, what is a VM scale set, what is a managed disk. Well, sometimes it needs information from the resource provider. So some interactions will go and talk to the resource provider. Now you might say, what's the problem? It gets slow. So yes, I can absolutely perform queries against the Azure Resource Manager, which could then go and talk to the resource provider to get the pieces of information. But there's actually, it takes some time because of all these different API calls and interactions. There's also a quota. So when I'm talking against the Azure Resource Manager, whatever those operations are, there's a certain limit to those. And you can almost think about every piece of information I need, every call. Let's say I was getting all my VMs and I had thousands of VMs. And part of that query then had to go and talk to the resource provider, had to do an iterative communication to the resource provider. That's one operation. So I may, in a big environment, actually run out of quota to be able to handle this. And we can see this. So if we jump back over for a second, we go to our VS Code. And this time, let's open up our resource graph demo file. So all I'm going to do is I'm going to run get Azure resource group, a specific resource group, but I'm going to do -debug. And what debug does is it actually shows me the headers for the API call we're making to the Azure Resource Manager. Not a big deal. So we got our result. Fantastic. And we can see the JSON body that was the actual result that was sent to us. But if I keep scrolling up, well, we can see the headers. So this is the header that was returned to us on top of that request. And the one I want you to pay attention to is this one. Rate limit remaining subscription reads 11,999. So I can make 12,000 calls an hour. Now that sounds like a huge number. And it is. That's a really big number. But it's not infinite. And I could think about if I did have a really big subscription, maybe I was running this fairly frequently, it's slow to do each of those communications every single time, but I might actually hit this quota. And then what I'm trying to do just won't work anymore until the hours passed and my quota gets reset. So that's obviously not an ideal thing to happen. And so we have the resource graph. The resource graph I can really think about as a separate database in Azure. So if I was to think, well, okay, there's normally the Azure Resource Manager that I interact with and I can make API calls and it does its thing. But what's also existing in Azure is really a database. So there's this big database in Azure and it's doing two different things. So periodically, it's just doing a full scan of the resources and it writes this data into this database, but it also gets notified of when any updates happen as it happens. So it's pretty much up to date. And it exposes its own endpoint. So there's something called the Azure Resource Graph. Well, the Azure Resource Graph can go and make requests and return me the results. I cannot make changes to my resources. The Azure Resource Graph is a database. Think of it almost as an inventory of the resources and certain key metadata. So it does not have every single attribute. So at a certain point, it may not have the information I need. It's pretty vast, but there might be a certain times I can get a bunch of information. Then if I need to get into some very minutia type detail, well, then maybe I have to write something to go and get particular things from the resource provider. Hopefully they wouldn't change that often. I would cache those. But what I can do is I can make requests. And I make requests using the Custo query language, which we saw with Azure Monitor Logs, Log Analytics Workspace. So it might give you a hint of what this database is built on. But this is a phenomenally powerful analysis language that I can now use to find out information about my resources without using up this quota. And it's fast. I could be getting information on literally tens of thousands of resources and it will be sub-second. So it's a world apart from if I was doing this iterative communication to the Azure Resource Manager and trying to get bits of information. So here, and we'll see this in a second, so it provides a read-only interface, but it also lets me do change tracking. So that inventory it's doing, it also tracks when attributes change of resources. So now I could say, well, hey, this thing broke at this time. What changed on the resource at this time? So it's a really powerful capability. So let's have a quick look actually at this in action. We can see it through the portal. So if I was just to go to Resource Graph Explorer, we can see options here. It says the Resource Graph Explorer lets me actually go and look at the way it's storing the data. I can run queries, and then there's actually just queries themselves. But if I go and look at the Graph Explorer, we can see different categories. So maybe it's, hey, for virtual machines, we can see down here. These are all the attributes that it has available to me that I could query and get information around. So this is all the different categories of data I can have. And it's got some example queries down here as well. So hey, count Azure resources. So it's querying the resources table. So if we actually looked at the table, I'll see there's the resources table. And it's going to show me all the different attributes of the resources table. And it's just using the KQL to summarize count. So this would just tell me very simply, well, how many resources, and these are all the attributes it's storing. So if I was to run this, I got 202. And you saw how fast that was. So down here we can see the speed, 0.221 of a second. So really, really quick. Now with this, there is still a quota. So this isn't just an infinite thing, but the quota works very differently because it is this database, and we can see that quota at work. So if I jump over here, what I'm now going to do is via PowerShell, I'm going to try and find my virtual machines. Just show me the top 5. But I'm going to use this debug flag again, which once again will show me all of the headers. So if I run this command, yes, run that command. Oh. So I got my results. It told me there were 2 results. So that worked fine. Just all. I can see the debug information showing me here. There's the VMs, all good. But I want to see the header again. So there's all the information about those VMs. And this is all coming from that resource graph. And what I'm looking for is this. In the header, this time we have a user quota remaining. I have 14 left. But it resets every 5 seconds. So every 5 seconds, I can run 15 queries. So it's a very different number that I have available to me, but hey, it resets very, very fast. And the nature of the Azure Resource Graph is I shouldn't be bombarding this thing with different questions really, because it's summarizing, it's got all the data for me. I'm going to have to do a lot less operations to get the same amount of data I would have to do with the Azure Resource Manager. And I've just got some example queries, and this is Kusto query language. Hey, for example, here I've got, I guess we can just select this one. So I'm looking at the resources table again. Let's go and bring this. Now I could run this directly from this page, but I could also drop it into this query. So I'm looking at the resources table where it's a public IP address, where the IP configuration is basically blank. And I'm projecting out information about it. So the whole point here is, what public IPs do I have that I'm not using? And you saw another command I had there for managed disks that I weren't using. So finding wasted resource, hey, I can really easily do this with these types of capability. The other thing we have is change analysis. And this is working off the same thing, but what it's doing is it's tracking. Now this is supposed to be 14 days. In the documentation, what it currently shows is it's only storing it for, you can only query 7 days. I think it's reduced the scope for right now. But notice I can see all the changes that are happening. So we can see I started a VM, it populated certain attributes. So the OS name, it used to be blank in the old value. And then it wrote in the actual values. So if some resource just stopped working at a certain time, so it stopped working 3 hours ago, I could come in here and actually look and see, well, 3 hours ago, what changed? did someone modify something that's broke my resource? So this is a really powerful capability to get insight into what's happening. Maybe some automation run, don't know, but I could very easily go and see exactly what did happen. So the Azure Resource Graph, if you're just trying to get information about your resources, start there. Don't start with, okay, git AZ VM. Okay, for each VM, go and grab these properties. It's going to be slow and you may hit quota limits. Write it using the Azure Resource Graph, which is going to be so fast, no matter how big that data set, no matter how many resources you have, the Azure Resource Graph is going to be a much, much better option. Declarative. Why? What's the big deal? So this is Jean-Luc Picard. If you've ever watched, maybe to people now are younger, they may not remember this so much, but he had this fantastic idea of make it so, number one. I want to be at blah, blah system, make it so. He didn't say, hey, look, engage hyperdrive, probably put in some coordinates first, move the stick up a little bit, and then push the stick forward a bit more, mine that planet. He didn't care how they did it. Didn't care where they currently were. You could have been there already. I want to be at Helion Prime. I just watched Riddick. I want to be at Helion Prime, make it so. And we're literally here already. Okay? Or I could have been the other end of the universe. I want to be at Helion Prime, make it so. Doesn't care about the current situation. Doesn't care about what's required. We have to fly through Klingon territory. Don't care, make it so. Fight the ships on the way if you have to, just make it so. All I care about is the end state. I'm not saying anything about how to get there. This is what I want to be. You, in this case, Azure, make it so. I'm just describing the end state to you. It's your job to work out where we are today. Maybe the resource doesn't exist. You need to go and create it. Maybe the resource exists, but it's got some configuration wrong. Change it to match what I want it to be. So we say only the desired end state. That's the whole point about this. So before we go any further, so think about that. So these are all imperative. I was saying do this action. If we flip this on its side, and now we're going to say, instead of that, I'm going to have a file. Now there are different formats. I'm just going to basically call it a template. And the whole point in this template is I describe the resource, I describe the properties, the attributes I want to be the case. This is a storage account. I might say a storage account called John. I want it to be locally redundant storage. I want this encryption. Maybe I also want a database. I'm just describing what I want. And again, there's many different formats. Like there's ARM JSON. There's Bicep. These are both first-party Azure solutions. There's things like Terraform. This is third-party, but it has a very powerful Azure provider, so we can go and create these resources in Azure. And all I do is I define this template, and all I'm doing is describing my desired end state. There is nothing in here that says create a storage account. All it says is, I want there to be a storage account. By the time you've finished doing this thing, there should be a storage account with these properties. There should be a database with these properties. And it still applies via the Azure Resource Manager. And the whole reason I keep stressing this point of it all goes, there's no bypassing the Azure Resource Manager. Because remember, what did the Azure Resource Manager do for us? Well, some of the huge things about the Azure Resource Manager, remember, was things like policy was enforced at the Azure Resource Manager. Role-based access control was enforced at the Azure Resource Manager for the control plane. So the reason I keep stressing, hey, this all goes via ARM, this same direction, is because none of these bypass. There's not some back door where, hey, I don't want this policy to apply. I'll use a template. Doesn't exist. Everything you do goes through ARM. So everything you do will have policy enforced, will have RBAC enforced. They all track the same way. But all I'm describing now is the desired end state. So if this was imperative, the AZ CLI and PowerShell, I'm telling it how to do something, this technology instead is declarative. This is how to do something. And so if imperative was great for automation, then declarative is fantastic for provisioning. And this is the key point. Anytime I should be creating resources, I should not be writing a script to create VM, create database. Again, because if you wanted to change that configuration, it's really hard to do. It'd be a second script that goes and checks, is it there? With a template, if I only need to change the configuration, I just change the template and apply it again. If it exists already and it matches the configuration, it doesn't have to do anything. If it doesn't exist, it'll create it. If it does exist but it doesn't match the config, it will change the config. I don't have to worry about that. So it's idempotent. I can run this again and again and again. It won't do any damage. It just always makes sure. And also because it's describing the end state, if the resource exists already, it's really easy to detect drift. So I can just say, okay, well, here's the attributes of the resource that exists. Here's the attributes in the template. Oh, they don't match. Oh, I'll rerun the template. There are automated solutions that will detect, hey, this is what's different between these. So this is really powerful when I want to have those capabilities to, hey, I need to be able to detect if a resource doesn't match what I said anymore. And when we think about DevOps, when we think about infrastructure as code, well, this is infrastructure as code. I'm describing the resources as code. It's readable files that I can use. And while I'm stressing the idea about Azure using these declarative technologies, they can go within the resource as well. So great. These templates, JSON, Bicep, Terraform, in fact, Terraform goes beyond that. In fact, most of these are starting to go beyond that. Yes, it will create the Azure resource. Think of a VM. Within the VM, there's a guest operating system. Well, there are declarative technologies to configure inside the guest. There's PowerShell DSC, there's Chef, there's Puppet. Kubernetes, well, I use a YAML manifest that describes the resources, the services that I want stood up on that Kubernetes cluster. That's declarative. Hey, these services should exist with this number of replicas. So it's not just declarative in terms of defining the Azure resources. I can then extend that out to declarative to define what's inside the resource as well. Again, there's different options. There's not a right or a wrong. We'll have a quick look at these actually. So they're easy to modify. I just change the desired state. I have full version control. Because it's a file and it's readable, I can check it into a version control system like Git. And we'll see this later on in this module. So it's very easy to track and see what's changed between the versions. And yes, as I mentioned, it's the Azure Fabric, but it also goes beyond that into guest configuration, into Kubernetes, Helm charts. They all work a similar way. So let's dive into ARM and Bicep. So under the covers, everything in Azure is actually ARM JSON. So it's JSON configuration. I think this is actually going to open up the resources.azure.com. There's actually a site you can go to. So there's resources.azure.com. And if you start poking around in here, I can look at my different resource groups. And what this is really just showing me is, well, here are the JSON. See which resource providers it's using. Storage accounts, and there's storage accounts under here. This is showing me the JSON format for that resource. So behind the scenes, everything is ARM. I can also see this from the portal. So if I was to go and look at a storage account again, storage accounts are very simple. They're a nice thing to use as a demo. If I've just got resources open here, let's collapse this down a little bit. There's actually two things I want to show you here. Firstly, there's a JSON view. So what the portal is actually doing behind the scenes is it's making a bunch of API calls through REST to the Azure Resource Manager. It gets a JSON response, and it shows it. That's all it's doing. So this is the raw JSON. So this is actually the configuration of the object. And there are different API versions, and maybe sometimes I want to see the result from a different API version. I can actually go and change the data I get back. If something's in preview, for example, sometimes I want to mess around with the API version. But also it does show me this CLI PowerShell. And what this will show me is some hints around, well, look, if you want to interact with this resource for the AZ CLI, here are some commands. And it's actually giving me specific commands for this particular storage account. So there's a whole bunch of different commands here for my storage account. Also, it gives me PowerShell commands for this storage account. So it's a nice way to quickly get some help. But the key point here is everything is actually JSON. I can even dump out, if I go down to automation, there's an export template. Show me the JSON for this resource. And what I could now do is I could export this out. I can save it. I can actually save it as a template in Azure itself, but it's creating me a template with the various parameters, the things I could change that I could then go and use. It's obviously tired this morning. I think when I record at Sunday morning at sort of 4 a.m., it's just not woken up yet. But here we go. So I can see that, and I can even see the parameters it makes available. And then I could actually get scripts that could go and use that template. So it's a really helpful, but it even says, hey, visualize the template. It says an Azure resource visualizer that helps me go and see exactly what it's going to do. It's not very interesting because it's one resource. But I can now go and save these away. I can download them, add them to a library, or even go and deploy it. So everything behind the scenes is JSON. And so when we think about a JSON template, what we're doing, if we jump over to our ARM templates area, is let's look at a really simple one. So storage account is always popular. So this is an ARM template. And you notice down here, it's saying loading ARM schemas. So I'm using VS Code. So VS Code is going to help me with this. It's going to give me some nice IntelliSense and some guiding around creating an ARM template. But we see we have a certain API version, and then we have parameters. So parameters are things I can change. I can pass in either through separate parameter files, or I can actually override the parameters when I call the template. And then we have some variables. So in this case, I'm creating the storage account name based on the resource group name, and then, hey, just a standard storage account. So this storage account will be based on the resource group name. Storage accounts have to be lowercase. They can't have spaces in them. As you can see here, I'm just replacing any dashes. It can't have a dash. So if there's a dash in the resource group name, I'm removing it. So I'm doing some little manipulation on the string. Then we define the resource. Well, it's using the Microsoft.Storage resource provider, and then the storage account's resource type. Now I'm defining the attributes. Okay, the name, I'm going to use that variable I created, certain location, there's a certain SKU type. So in this case, it's a storage account type, which I pass in. It's a storage account v2. I'm just going to dump out the storage account name as this string. And it's going to be the storage account name value. So that's me defining this resource. And that's all this does. Now I could deploy this template directly. I have a parameters file where I'm telling it, hey, the type is standard locally redundant storage. And I could just run that deployment. Now my resource group name, I have to keep messing with these because I make these available to people to try and help them, and they just create these resources and steal my name. So if I go in there, there's my path. Now if I looked at my resource quickly, So if I look at that resource group, let's look at my 007. Oh, I'm looking in storage account. That's why it's wrong. But what you can see already, so in this storage account lives in this particular resource group. So I have it created. What I'll do, well, actually we can show a few different things. So I'll delete it actually first. So let's just delete that storage account. So we'll delete the storage account, which will free up the name. Storage account names are globally unique because of the way the namespaces work for a storage account. So what I could now do is, we've defined these things, we could run that template. So this will call the template to go and do whatever that template has specified should exist. In our case, it should go and create a storage account with the name RG007007 in it, because that's the name of the resource group. And I just create the storage account name based on the resource group name. So that will go off and create that resource. So it finished. It says succeeded. We can see the time in GMT, I'm guessing that is. Yep, 6 hours from now. Notice the word incremental. We'll come back to what that word means, but it was an incremental, that's the default. And now if I go and look at my resources, the portal always lags behind a little bit. So the portal's only 30, 60 seconds behind. But eventually we will see a storage account show up here. No, try again in this view. Come on. It will show up. So we know it's there. If I ran the command again, in fact, what we'll do is we'll run the command again. And I'll do what if, but I'm going to pass it a different storage account type, GRS this time. So what it's going to do now is it's going to say, okay, what is the configuration I'm looking for? And I've overridden the type to be, I want it to look like a standard GRS. It will look at what exists, and it will say, this is what I would do if I didn't have what if. So it would actually rerun it. And notice it does know it exists. It's just the portal's behind. But it says, well, here's the difference. This is what I would do. I would modify it to change it from LRS to GRS. So now think about my experience as, it's still not showing up in the portal. The portal was very behind this morning. I now don't have to worry about commands to change things, to modify. All I now do is state my desired end state. That's it. That's all I have to do. Everything else is the problem of ARM. It has to go and work out, hey, this is what they're asking for. This is what I would have to change to actually make this a reality. Let's actually just come out of this. I don't know why that is. Oh, because I'm looking at the storage account, not the resource group. I think I'm being dumb. Let's go back to the resource group view. I'm hitting refresh again and again. No, it's still not showing up. I don't know what is going on. But that really should be there at this point, because that is the resource group it's creating it in. And this was the change it would actually make. So it would change it from standard LRS to GRS. And what we could even do, to wait for it to show up at some point, is I'll take out the what if, and we'll just run this one as well. To show that, hey, the resource exists already, and I'm just overriding one of those parameters to say, actually, I want it to be GRS. I'm not telling it how to change it, but we can see now what it's saying is, yep, I finished, and I did an incremental again. The storage account type is now standard GRS. So I can see it actually made that change. Oh, there you go. Now it finally showed up. And if we look at it, okay, so the portal, again, is behind. It's still showing it's locally redundant from where we initially created it. But at a certain point, oh, there we go. Now it shows us GRS. So all we're doing in declarative is saying what we want. That's the whole point. But that's so powerful. It's a game changer in how we work. So we talked about, hey, we can see the export options. There's a huge library of starter templates. And what the quick start templates now show me is both the ARM JSON and the Bicep that we're going to see as well. So they're organized by different types of resource. If it's a 100, it's really simple. 200, a bit more complex. 300, lots of different resources working together. There is the extension for VS Code that helps me architect, design these templates. Incremental versus complete. So we saw that. We saw it said running in incremental mode. So my whole point here is it's declarative. I'm telling it what I want to exist. Okay. So I have my template. So just to keep it orange, we'll keep the template as orange. So I have my template, and this doesn't matter if it's ARM, JSON, doesn't matter if it's Bicep, whatever this is. So we'll say this could be JSON, it could be Bicep. Because Bicep, we're going to see in a second, actually just compiles, transpiles into JSON. So we're listing our resources. Now imagine we're deploying it, obviously, to Azure. So we're deploying this into, and we're targeting, in this case, a resource group. So let's say this is called resource group 1. Very simple. What we'll actually say is, instead of just me drawing these like very, very basic lines here for a second, let's say we're actually defining storage account 1. And there's its attributes. This resource group already has existing in it something. Maybe it's already got a Postgres database 1 that exists. When I deploy this template, so now I'm going to do a deployment, I can pick a deployment mode. Now let's say I picked complete. Complete says make the resource group exactly match what is defined in the template. This is not defined in the template. So when I apply this in a complete mode, and it will give me a warning. It's like, do you really want to replace everything that exists with what's in here? And if I say yes, well, it's going to delete this because it's not in here. And the only resource I will have left is the things defined in the template. So use complete with caution. It's assuming everything you want is in this template. Anything that is not in the template will get deleted. My other option is the default. So in the default mode, again, can be the same types. This time, maybe I'm defining Cosmos DB1 and its various attributes. I'll deploy it. This time I don't specify mode, or to be safe, I'm going to say, hey, I want this to be incremental. What this says is, hey, the resources I have defined, make sure they exist and make sure they match my configuration. So it would go and create Cosmos DB1. But it would not change things that exist already. That's the huge difference between them. In fact, I'm going to draw this in a different color. So I'll make this Cosmos DB1, because that was in this file, just so we can see the difference in the interactions. So this was defining Cosmos DB1 and its attributes. Because it was deployed in incremental mode, hey, the resources that I'm mentioning here have to match this configuration. I should create them. They should match these attributes. But if it was there already, I don't care. Leave it alone. I'm incrementally provisioning resources into that resource group. So that's the point. But it is really important to understand the difference between them, because if I accidentally go and do a complete, it's going to wipe out everything else that's in that resource group. So normally complete is maybe in very specific scenarios where I can only have these. I don't want anything else. I'm doing it a very deliberate way. Great, you can use complete. But ordinarily, use incremental. Hey, I want the resources I define to match this. But if there's other stuff, don't worry about it. I don't need to know. I can do more advanced configurations with templates. Now, I'm not going to go through them in detail here, but super quickly, if we jump over to VS Code just for a second. So I've got examples in the file, so you can go and look at this. But here I talk about the idea of nested templates. So here, with a nested template, I'm just referencing another template. I can deploy a linked template. And the point of a linked template is it could be stored somewhere else completely. So I could actually have it stored, for example, as a blob. I'm actually going to take that out. I don't know why I put that in. But there is some URI that I would have in there that you would populate. So I would actually go and get the shared access signature to my file, and I would put it in here as part of this. So I can reference things both locally, I can reference things remotely on some other server somewhere. And I've got examples of these files in the repo. So hey, the linked to GitHub as a file, for example. So I've got my parameters, and I've got here a URI. So this is actually using a file from the masterclass for the content of the template. There's an idea of a linked local that I can leverage. And I've also got template specs. So template specs is a new type of resource in Azure. So if I was to go back to the portal, if I search for template specs, what this lets me do is basically just save versioned versions of templates as first-party Azure resources. So this is really nice. I can have my own little library of templates. I don't have to go and reference a file somewhere or anything else. I can reference them from other templates, and they're just available to me. So go here. They're just available that I can leverage when I want to create resources now. So it's first-party Azure resource. It's an Azure hosted mechanism for my templates. That's really what it is. But it has role-based access control. I have to have read permissions to be able to use a template spec. It is versioned. They're very easy to reference from other things. I can use it anywhere a template can be used. So this basically just makes it easy to share with other people if I need to. I can still have parameters to make them behave differently in different environments. I could use Bicep. So I'm showing this under ARM JSON, but if I use Bicep, it will store it as JSON, which will make more sense in a few seconds. And the reason I keep going on about parameter files is right now I keep drawing this idea of Azure, an Azure environment, a resource group. Remember that most of the time, you're going to have maybe a non-production, a dev test, and production. And what I don't want to do is change my template between environments, because then I'm breaking the whole point. I want to define this infrastructure and resource once, and I want to make sure there isn't a change between dev, test, and production. But it's like, well, that's problematic, John, because I call things different between my prod and my non-prod. So maybe over here is my sort of non-prod environment. And that was prod, for example. And although I want to create the same resources in both environments, my naming is likely going to be different. I have dev as part of the resource name. I might have maybe a smaller instance or something. I'm referencing things in a different way. That's why I have parameter files. So it would be one template. The template would be exactly the same. The template is not changing. I have my template here, and it's the same template I deploy to both environments. The same template, the same version, exactly the same. What I can change during that deployment is, well, for prod, I have prod parameter file, and the prod parameter file has the naming I would use for prod. And then I would have a very different parameter file name. I have my non-prod .pram for non-prod. Same ARM template, be it JSON or Bicep or Terraform, doesn't matter what it is, the parameter file is different. So it's the same resources, but here I can tweak the actual values for certain things. Maybe I use a smaller SKU. Maybe I use different naming. Almost certainly I reference some different secret. But the actual configuration of the resources, the ones I'm deploying, they will be the same. So that's why we have parameter files. I want to make the template usable across different environments, maybe completely not just non-prod, different projects. And then the parameter files let me make it specific to a particular deployment where I need that. So this is the whole point. So template specs, well, hey, I could have the template stored, then I could have different parameter files when I call the template spec for the environment, for the project in which I'm actually using it. So this is the point around that. So that was ARM templates. And the ARM templates are great, but they're really big. They're really verbose. So ARM can be very intimidating. I look at it and I'm like, oh no, where's the portal? Click, 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 click. So Bicep is an alternate language which compiles to ARM JSON. And I say compiles, I think the correct term is transpiles, because it's really converting one structure of text to another structure of text. So if I think if this, and I'm going to take out the word Bicep here. This is JSON. So these are going to JSON files. So in this line here, I'm working with the Azure Resource Manager JSON, which is great for Azure. Azure loves the big verbose JSON format. For me as a human being, it's like, wow, this is really big. This is ugly to work with. So I, as a human being, I would much rather work with, let's do a different color. That works. Bicep. It's still declarative. It's just a different structure within the file. I'm still defining what I want the resources to be, what I want it to look like, but it's a lot less verbose. It's much easier for me as a human to work with. And when I do a Bicep deployment, I can deploy it directly to Azure via the Azure Resource Manager. All of these are going. All of these, I'm drawing it to the resource group. But again, to really stress that point, and I may be overstressing it, this is all actually going via the Azure Resource Manager. I'm never bypassing. So whether it's Portal or PowerShell or AZ CLI or templates, it's going via ARM. So my policy, my RBAC always applies. I can deploy Bicep directly, but what it's really doing behind the scenes when I'm using it is I think it's transpile. It's converting the Bicep to JSON to do the deployment. If I save Bicep into template specs, it's transpiling, it's converting it to another structure, which is the ARM JSON. And it's got the same capabilities. Again, it's using the same resource providers that ARM JSON is built in. It's just a lot easier to create and understand. It has its own idea of modules, so I can break functionality up and use them for multiple different projects. And again, there's a great VS Code extension. Oh, didn't mean to go forward there. So just super quickly, we can look at a Bicep file just so you can see it's nicer. So if this was JSON, let's close some of these down. Oh, I opened up so many files. Sure. So remember, this was a storage account. All of this was a storage account in ARM. If we go and look at Bicep and look at the storage account, this is the Bicep version. Hey, I want to create a resource. The resource's name within this file, this is all it is, so I can reference it. It's going to be STG, storage. Once again, I'm using storage resource provider. I'm using storage accounts resource type within the resource provider. And this is the API version. The name of the storage account is going to be the name parameter. I don't have to use special things. It's smart enough to understand. Hey, it's a storage v2. The SKU is going to be the name. I'm referencing a variable. Output to me, the storage resource it creates. Remember, it's referencing the STG up here at the top because it gave it this local name. Its attribute ID. So it's a lot easier to see, but it's doing the same thing under the covers. It's just for me writing it, it's a lot more pleasant. If I was to take that out, for example, so I don't know, if I start typing, notice it's giving me the IntelliSense. Hey, do you want to do location? Yeah, I do. And then notice here straight away, do you know you've got some nice little parameters you could use here? Sure, use that. So it's a really nice experience. And if I'm not even sure what I'm doing, it's going to show me the things that I'm missing. I've actually completed most of the options, I think, here. But it would show me the things that I could have to help me complete this. So this is the whole point. It's a lot easier for me to write, and it's a lot more pleasant for me to look at compared to this. But again, I can actually compile this to JSON. So if I have this file, I don't know if I changed that. Don't save that one. If I was looking at my Bicep demo, I could deploy the file just like I would deploy an ARM template. I'm not doing anything different. Hey, I want to do a new AZ resource group deployment. But I can also build it. I could actually build the storage.bicep file and it would show me the ARM template it would create. I don't have to do this. Again, this is just going to be done automatically when I do a deployment. It creates the ARM behind the scenes. But if I wanted to actually look at it, I can do that. There are other things I can do here. I could actually have an ARM JSON file and it will decompile it to a bicep file for me. So if I had an ARM template, and I'm actually curious what the bicep would look like, well, I can do that. And I ran that down here. So here's my JSON file that I've got right here. One of the things I could actually do is, well, what would the bicep look like of that file? So if once again we create those. Now with bicep, you do have to install it. So there's a VS Code extension that will get added and prompted. And there's different ways. The documentation will walk you through how to install Bicep. And I've just realized I may not actually have it installed on this machine. Oh, I do, thank goodness. So you can call Bicep directly. And if we tried it out, so we define those variables, let's try a decompile. And what it did is it created me this file over here. That's a pretty good starting point. So it went and created the bicep file for me that I would now maybe go and leverage. Again, most of the time now, it actually, I'll leave that there in case you want to go and look at that. Most of the time now, if you look at any samples, it will have a bicep version as well. So you probably won't need to do this. It will just have a bicep for you. But if you didn't, if you had an ARM template and you were curious about it, well, hey, you can actually take an ARM file and decompile it to a bicep file. So it's a kind of cool thing. So if I was a human being and I was like, okay, I want to start doing declarative creation of resources, I would use Bicep. I would not use ARM JSON, I would use Bicep. It has all the same capabilities. It's a lot more pleasant for me to use. Now, I did mention Terraform. So just so we're clear, Terraform is third party, but it has a fantastic Azure resource provider, Azure provider, which lets it interact with Azure. But Terraform supports many other types of resource. So it can do Azure, AWS, Google, Kubernetes, VMware. So if I was cross-platform, if I was hybrid, if I wanted one declarative technology that I could use everywhere, I would probably use Terraform. I don't want to have to use one technology for Azure, one technology for AWS, one technology for VMware. I could just use Terraform that would work across it. And once again, Microsoft works very closely with Terraform, so it's Azure provider. I think for most part, might be a little bit of a lag, but would have the same capabilities. So the key point here, there are different interactions. Portal, very intuitive, great to look at stuff, great to investigate. PowerShell, the AZ CLI imperative, great for automation, stop, start, whatever that may be. Templates are declarative, fantastic to, this is what I want it to be, make it so, fantastic to detect drift. I use them for provisioning. So they each have a certain place. While yes, I could automate provisioning with imperative technologies, it's not the best way of doing it. I can't easily modify. If the script crashed halfway through, I can't easily fix it. Templates, it may seem a little bit more intimidating at first. It's a much better option. Now, one of the things I stressed, both for the imperative and the declarative, they're files. At the end of the day, they're files that I have to store somewhere, and I'm probably going to change them over time. And if you're anything like me, I have a folder. So what I have a folder on my machine. So I've got some folder. And I have my files. I got my file 1, file 2. And it's funny, I look back at some of my older code before I really understood version control, and you would say folder V1, folder V1.1, file V1, file 1. Like you would have these ton of file names as you change different versions, current. And it's ugly. It's really hard to manage. And I imagine there's multiple people you're trying to share this with. You're trying to collaborate on things. This sucks. Obviously, it sucks. But it's there, and I have this. I still need to work on files, so I still need somewhere I can work. So I need some working area. But I want a better way to track versions of files. I want a better way to collaborate with other people. So enter Git. Now, what I want to stress actually here is that when I first did this Azure Masterclass a couple of years ago, I had to cover all of the things around what was Git, what was DevOps. I have a separate DevOps masterclass now. It's free, just like this one. And I have a 2.5-hour module in that course just on Git. So I'm not going to try in here to go into details on Git. I won't do as good a job. I have a few videos that I consider everyone should watch. My video on Git is one of them. Everyone should have an understanding of Git. If you're a programmer, if you're a administrator, pretty much everyone should understand Git. Because Git, what this is going to get me, there we go, I can have different versions of projects. I can have different versions of files. I even have ability to branch out and have branches. I just think of branches as I could maybe have my main project. Then maybe I'm working on a bug fix. Maybe I'm also working on a V2. Maybe I'm working on some special enhancement. Well, all of those different tasks may be working on the same files. So ordinarily, you'd be tripping over each other. What branches let me do is I can have, almost think of it as different views on the files that different groups could be working on. So you're not tripping over each other, changing the various code. But then at a certain point when you're ready to collaborate and you want these constant bringing things in together, I can merge my changes with the main branch, with the changes from other people. I could rebase what I'm working on. Maybe there's been some advancement. I want to bring that into the code I was doing. And these tools help me see, well, maybe there's no clashes, in which case it would just bring them in together. Maybe there's a clash. They did change the same line I changed. Well, I can look at those and work out, okay, well, how do I now, as a human, bring those things together? But it helps me collaborate, and I want to not wait till the end of the project. The whole idea is I would constantly want to check in and bring changes in together. So it's not some hideous, massive delta at the end of my project. I'm constantly bringing them in together, so I know there's going to be a fairly healthy and small incremental changes if I have to. Many online repositories today are Git-based. They just are. So Git is not particularly a product as such. There are Git tools, but it's a certain standard around how it does its version control, how it stores them, how it creates commits and checkpoints and views in time. So I can go and download the client tool. It's free, git-scm.com. There's a fantastic book, it's free, that goes through all of the different elements, explains all the concepts for you. But then it does work with many online repositories that are Git compatible. So I don't have to think of some special thing. It's not some unique implementation. It just works with the various commands that I use for Git. Now the whole point here, and let's think about this. If this was my working folder where I had files, well, I want to start using it with Git version control. So I've installed the Git client. And the first thing I would actually do is, there's two ways I could do this. But let's assume we've already got a working folder and I want to start just doing version control locally. Forget about any online thing. Me, for my project, I would like to version control. So once I've installed the Git tool, if I run the command git init, it basically sets up this current folder now with the Git tools. It will create a hidden .git folder where it does its internal tracking. And this now becomes the working folder. So working is where I work on the files for Git. So I update my files, I make changes, and then what I want to do for these files that are in my current folder that I want to start tracking, because by default, all I've done is create this empty Git repository. It's not tracking anything yet. When I have files, maybe I want to add everything initially, what I have to do is I do a git add. So I do a git add, and now what it does is think of some internal structure. I don't see it, but what it's really doing, it has a staging area. So these files would now be sitting in staging. And then I have the main Git repository, which remember, is really being powered. There's not some service. There's no daemon running. There's no service running. There's not some remote port it's talking to. These are all actions on the local file system. So this repo is really this .git folder that's a subfolder of the folder where I run the .git in it. And so when I'm ready, when I've got these files, I make a message, okay, I've done these changes, what I then would do is a commit. And what the commit will do is it will say, okay, now these files, this is a new snapshot of the entire structure. And the way this works is we have a branch called main, which is the default. And then there's a pointer, there's a head pointer, this is where we are. Because really this commit is really a checksum. There's a checksum that references a certain value for that particular commit point in time. And all I do is I iterate through. I'm like, okay, I changed this file too with some change. Okay, I want to save that. So I basically at this point, I would add that to staging. I might add multiple files that make up some certain set of changes. And I do a commit. When I do the next commit, that becomes the new main point in the branch. And the thing that tells it I'm at the start of the branch would move. So now it points to this one. So really you can just think about it as a timeline. It's just this timeline, and every time I do a commit, it's a different snapshot in time of everything. And that's a key point. It is not just looking at the change in the file. It snapshots the entire content of the structure. Now it's efficient. It's not wasting space. It creates a hash value for the blocks of the files, and only if there's a change will it store it again. It can reference existing blocks as part of this. It does compression functions. So it's still very efficient with how it's defining things behind the scenes. But essentially, I just have these points in time. And again, if I needed to work on something, we don't actually normally just commit directly to main, we would create a branch. Hey, I'm working on this little new release. I'd create a branch off of here. I'd do commits against my branch. So I'd create a new branch. I'd be working on it. When I'm finished, when I've completed my work, I'm just going to delete these ones. I've completed the piece of work I was working on. Well, now I'm ready for it to bring into main. I would merge. And now it would be a new commit on main. So I do a merge action to take the contents, the changes I've made to here. Now you'll notice there's been changes made along this branch. So there might be, well, were there clashes? Sometimes I can do something called a rebase. And what a rebase does is my code, well, it would rebase it on the current other branch that I want to merge to. So I could resolve any problems ahead of time and then merge it into that branch. And they're more complicated concepts. I'm not going to go into a bunch of detail about that. But this is the whole point. So typically we will work on branches. We don't just commit to main. We'll work on a branch. We'll complete our feature. And actually what we'll do is when we want to merge into the main branch, we'll submit something called a pull request. And a pull request says, hey, I want to bring this into main. There's probably going to be some approvers. They're going to do some checks. They might do a build to make sure it's valid. And then once they pass these various checks, they'll actually go and bring it into my main. So if we jump over here just for a second. So if we now look at little get demo script. I'm not going to go through all of this. I mean, the point is you can, hey, check, do I have get installed correctly? So I've got a certain version. It's probably an old one. When you get started, there's two things you have to do. You have to set up a global username and your email. This is how it tracks various things. So I've set those up in my environment. If I was now in a folder that I had not done anything else to, if I want to start tracking changes, I run git init. So if I was, actually let's just move to a completely, what folders do I have here? CD scratch. So there's a few little things in this folder, and that's just what I'm going to do while I'm doing this, just so you can see what it does. So this is currently not a tracked folder. So if I look at this and I look at Scratch, so there's some Win64, I don't even know what that is. I'm just going to delete that actually completely. Let's delete that. I've got one file in here. It's just an image. But there were no other folders. But if I run the command git init, it's now created an empty repository. And it created, you can see here, that .git folder. So straight away now, we can see this hidden .git. And this is how it stores all of the things we do. But right now, it's not actually tracking anything. It's empty. Even though there's a file in the folder, well, Scratch is just a working directory. There's nothing actually in it yet. But what I could do, I think I've got some examples further down. So I've got this whole tracking, so you could try this out if you really wanted to. But let's say I could, hey, echo to a README file. So I've now created a file, if I look, called README. And what I could do is if I want to start tracking the file, I can do get add. So if I run get add, that's now tracking that. It's now in staging. Now, it's not actually pushed it or committed it yet. It's just got it ready for here. If I do get status, we can see right now, hey, look, there's a change waiting to be committed. And there's also files you are not tracking. I would have to do a get add on these to start tracking these files. I could add everything. If I did get add dot, it would add all of those files to be tracked. But if I was ready, I might say, okay, I'll do a get commit. I have to give it a comment. So adding my README and done. So it's now completed that. So if I did my get status again, I've got nothing that's just being staged that's not ready to go. And then I could modify the file, I would do other changes, and I'm just working through my overall structure. Now, if I went back to my, just actually close that for a second. Let's do, I want to do a new terminal. Where's my terminal? Oh, there we go. Let's open up a terminal again. Okay. I'm in my Azure Masterclass folder. This is a view of all the things that I've been doing on this masterclass. So what you can see here, I'll go through the whole history. I made a lot of changes. But you can see, oh, there you go. Where I currently am, I have that head pointer that I'm on the master branch. It's normally called main now. This is an older repo. But you can see that I've made changes. I'm describing the Git commits. You can see sometimes where I create a branch and you can see where they join back together, where you merge the things in. You can see pull requests were made. I can see all of the code changes, but there's this entire history. And all of these little hash values, this is the end of the hash value. It's actually a lot bigger than this. But I can track everything I'm doing. Now that get graph command is not built in. Somewhere in this file, you'll see me define it. There we go. I'm just using git log, but I'm doing these decorators, graph, one-line summaries for all of it. So it just helps me visually see nicely what's happening to my environment. But all of this, and what I would recommend is seriously go and do that module in the infrastructure and the DevOps class. So if you go and use DevOps class, I think it's module 2 or 3, I have a master Git class. And definitely everyone should know how to use Git. It's just a core tool. And it's 2.5 hours. There's a huge file. You can run through everything I do. So I would definitely recommend everyone does that. So I could use it completely locally. But if I want to collaborate with other people, I probably want some remote repository. And GitHub is just one of them. So GitHub talks Git, but there's also Azure DevOps. There are other technologies. I don't even remember all the different names. There's buckets and labs and all these different things. But I want a Git server. It could be private. I could host this internally. So there's all these different services. It can be private or public. If it was obviously my corporate intellectual property, I don't want to put that on a public repo everyone can use. You can create a GitHub account for free, and I can create public repos. I can create private repos. I can add that public repo or private repo to an existing local repo I have, or I could go and create the remote repo first and then clone it so I have a local copy. And then what I can do is I can push changes. So if this is my local repo, great. What I probably want is, I'm going to use GitHub. And under GitHub, I can create repos. And you'll also see the logo is, I think it's normally like this, to signify the branches and the code you're doing. So I could absolutely just start, first of all, creating the repo in GitHub. I can go to GitHub, super easy. Let's swing over here and look quick. So if I was in GitHub, let's close that down. Actually, let's go up a level. So I could go repositories, and I could create a new one. Me, I'm the owner. I can put in a name, demo repo for me. I can say, is it public or private? Hey, create me a default README file and create repo. And I'm done. I've created a new repo, public or private. Now, what I have done is created a GitHub account first, so I'm authenticated already with GitHub. So that's something I've already done. I don't want to do that right now. So I'm just going to go back. So I have a bunch of repos already. If I look to my DevOps masterclass, Oh, it's part 2. So part 2 is that master git. I can see the files. So you can see, for example, here I've got this great big script, and this walks you through everything you're ever going to want to do with Git. So again, I definitely recommend going through that. But I made certain changes to this file. So I've got this idea of a history, and I can see the different commits I made on the file and when I made them. I could go and look at them. Notice there's these hash values for them. I could go and get a certain file from this. I could look at the changes between it. But if I was just going to go and look at the repo, one of the things you see in this code dropdown is I can clone. And it will show me the URL I need. And I could just do git space clone space this URL on my local machine, and it would give me a local copy. Probably do a space dot at the end to say do it to the current folder. So I can clone someone else's, and it would bring down a complete copy. Now, if this was my repo, when I did the clone, there would be a link between them, and it would, yes, populate a working folder for me. But then what I could also then do is push changes back up. So there's 2 things I could do here. Option 1, so we say option 1, I create it here first, and then I run a clone. And when I do the clone, it will go and create this folder. I take where I want it. It will obviously have the .git hidden folder, so it's got the local repo. It's a copy of this. The other option I could do is I could create it locally first, create an empty repo up here, and then as part of the configuration, so I would do a create. I mean, I have to create here as well. For both options, I have to create it here. But I would create and then add this as something called a remote origin. So now there'll be a relationship created between these, and then I can run commands. So if I've made some changes here, I've done some commits, and I want to push those commits up to the shared that everyone can see, well, I do a push. And that push will make those changes now available in the repo. So then other people could do a pull. And a pull really does 2 things. It does a fetch. A fetch says, we'll get the metadata and information about this, but don't change my working set. And then it will do a merge or a rebase to now bring mine up to speed so it will have the same commits and everything else. So it basically makes mine include all the changes that have happened against that remote. There's also sync options in the portals that will do a push and a pull, for example, for you. And this is all integrated actually with VS Code. And you've probably seen this already a few times. As I was typing things, it was sometimes showing you little bits of information. So this is a Git lens, and it's showing me, hey, I did this 2 years ago, and when I did it, here was actually the commit hash value of everything I did. So it's fully integrated. And if I was to actually go over here to source control, so right now, from our example, it's showing me there were 2 files that I've modified that I've not yet staged. So I would say, well, actually, yeah, I want both of these. So I would hit the plus in VS Code to stage them. So that would stage them ready. Then I would enter a message for the commit, small URL change for Git. The commit then takes the stage changes with this message and commits it, but this is only locally. That's the important thing to remember here. This is my local copy. So if I was to do my Git graph now, oh, did I go too far? Here we go. So this is quite interesting if I look at this bit of the Git graph, because it's showing me that, hey, mine, this is where I am. I have these commits. In fact, I have these 4 commits, whereas the origin doesn't have any of these commits I've been making locally yet. So all of these This is where my remote copy is. There are 4 commits changes I've made that I've not yet pushed. And if I hit sync, what it would do is it would do that git push for me. I can be more granular. I can actually see there's the git push here. You can see it also has all my commit commands. I could do a pull, I could do a fetch. As soon as I do sync though, remember this is to a public repo. So as soon as I hit this, everyone else, or maybe people I'm collaborating with, see these changes. Maybe I'm not ready for that yet, and I'm not. So I'm not going to hit that button. I don't want people to see module 11 changes because I'm still recording it now. I want people to see the files from it until I've published the video. So I would not do this, but it's integrated very tightly in with VS Code. The only things you have to do in VS Code is, if I remember correctly, if you go to Command Palette, you have to tell it the location of where you have Git. So there's somewhere in here, I can't even remember where it is anymore, but there's a location you can specify. There we go. So you give it the path of Git. Once I've told it where the executable is, it then has the ability to integrate with version control. So that's all I have to do to then be able to leverage that. And that's obviously super, super powerful to have those capabilities. I mean, GitHub is one option. There are multiple solutions out there, but at minimum, you don't even have to use a public service. But what I would recommend, just from a safety, you create a private repo. They're free. Have version control on all my code, my documents even, my images. Do commits at certain points in my project. Sync it up to a private repo. No one else can see it. It's only yours, but now you have a nice remote copy available for all your work. So definitely would recommend that. So that's Git. If that's version control, what is DevOps then? And again, I have a DevOps masterclass. Just like this one, it's really long. I go into lots of detail. But it's not a product, which is confusing because there's products called Azure DevOps. Products are part of a DevOps mentality, of a methodology. But it's really about this idea of people, of process, of tooling. So there are different combinations to it. But the whole point about DevOps is I'm constantly delivering value. These small incremental changes to the environment. So that was GitHub. That's Git. The whole point of DevOps, so we'll go to the universe cut. So we have DevOps. It's just a shift in how we think. But the whole point is we constantly want these small, incremental units of value. So I'm constantly bringing some change to the business that has value. Value to me as the business, value to my customers. But they're very small. They're building on what came before, but it's constant. It's this idea of a continuous improvement. You remember in the past, you had a project. Think of Windows. Windows was a great example of this. You had Windows XP. 3 years later, you got Windows Vista. A massive gap in time, but this huge change of functionality. And sometimes there were challenges with that because it took you years to be able to react, and maybe requirements change in those years. Then if you look at what they do today, every 6 months, or they're changing that schedule a little bit, but you get these moments, you get these smaller increments of value, so they can respond quicker. I see the benefit quicker. It's less jarring for me when they make those changes. So DevOps is, instead of this huge project that maybe can't adapt very well, and also imagine you misunderstood the requirements and the client you're writing this app for doesn't see it till the end, and like, oh no, you got it wrong. Whereas if I constantly show them little bits of change, they can very quickly say, actually, no, I want to go in a different direction, and you can adapt. So with DevOps, the whole point of this is, well, you plan, as you always do. So you plan and you track. And you'll see different tooling like Kanban boards, and you have a certain amount of work items can be happening. But there's this constant flow, and you add things move between stages, between different teams. But then you develop. So hey, I still have to write my code. Things don't change. And then I build some artifact, some executable, some image. Or then I build it. I have to test it. Then I would create a release of that. Then I would do a deployment of that to an environment. When I've deployed it, I have to operate it. And then the huge thing here is that we have to monitor it. Because then we're going to give feedback for the next planning, the next bit of tracking. And when we say monitor, this is not monitoring in terms of just, is it up and running? Is it healthy? It's monitoring of which bits of functionality are being used. So when we think of monitoring, it's observability. It's how is the client using the tool? What buttons are they clicking? What paths do they take through the solution? So I can work out what would be valuable. Where should I invest the next set of changes that would get the most benefit? Why bother planning and tracking and developing something that's barely being used? No, I want to observe what's happening to see what's being used, what would actually get real value. Let's focus on doing the next small incremental bit of value in that area. That's really the whole point. And the whole thing you see here as well is there used to be an operations team and a development team. Development team were incented to create new things. The operations team were really incented to stop new things happening because it would cause them problems. So they would clash. Well, the whole point of DevOps is you bring everyone in together. Now, there's still teams, but now your developers, they'll have some interactions with the operation of this solution as well. So they have a vested interest in making sure they create quality code. The operations people will be involved earlier on to understand what's happening, to understand the types of capabilities that's being introduced. So they have more of a say, they have more of an influence to make sure we're delivering quality, which is the whole point. These constant incremental units of value. Value is the point in what we want to do. And often because of these shifts, you'll see a shift in how you create the solutions as well. We might be used to in the past these big monolithic apps, and the developers said, it worked on my machine. Operations says, well, it doesn't work in prod because hey, the developer had a bunch of other stuff installed on their machine that they forgot to include in the documentation. In the DevOps world, we tend to move to microservices, we move to containers, where as part of the development and the build, they create these container images that include all of the dependencies. They get stored in a registry somewhere, and then there's a deployment manifest, a YAML file that describes which image to pull from the registry, the service configuration. So it's a much smoother set of overall deployment into the solution. Now, one thing this will often bring as well is we talk about the version control. And remember that version control is maybe for the source code for my application, but it's also the source code for that infrastructure as code, where we're actually defining this is what should exist and create that. So as part of DevOps, the other big thing you're going to see over and over again is this idea. I want to try and get a good color. We have the idea of a pipeline. So if I think that this is a pipeline, now they may have different names in different solutions, but this is all about continuous integration, continually integrating different people's codes together, different projects together to make sure we don't find some huge issue at the end. And then continuous delivery of that solution that I can then use, maybe even continuous deployment. We keep pushing it into live environment after we've gone through certain checking. So we're continually updating and bringing value. I don't really want humans deploying into production. In an ideal world, the whole point is everything should be happening via our version control. So we have that main branch. When I get commits into the main branch, because they've gone through the approvals, gone through the checks, when there is a commit, here, I want to start triggering things to happen. Now, I may also have things that monitor. Maybe I'm working on a V2 branch. I want to do the same. Hey, I do a commit. Let's validate this code has not broke something. So, hey, I do a commit. It runs off a build. It runs off a deploy into a test environment. It runs some load testing. Maybe I'm using Azure load testing, using those JMeter scripts. Maybe I'm testing it for failures using Chaos Studio. I can build all that stuff in. But hey, a commit happens to some branch. So here, I could think of, okay, there's been a commit, or it could be a pull request that wants to trigger a build to make sure it's valid before I accept it into main. But there's a trigger of some kind. Okay, well, the first thing I probably need to do is I have to build the thing. Then maybe there's some basic unit testing I can do against the thing. Then maybe I need to do an image create. And I go and store that, for example, in some, if it's a container, some registry. It's a different service. Then, okay, I want to deploy it. So this is a dev deploy, so testing environment. And then obviously it would pull that in as part of wherever it's deploying to. Then there'd be some testing, load testing, chaos testing. And what I can also do is I could have, then maybe my final thing is prod deploy. But I can have gates. I could define gates that say, hey, we've not raised more than X bugs, or these tests hit this certain level. So I can have gates between different things as part of this pipeline. But the whole point here is, as part of this, I don't even know where my environment went anymore, over here, this arm. So this deploy would then go against the Azure Resource Manager. I'll just do a different cloud at this point, I think. But that deployment would just happen. So, what do I have? 3 orange pens. I've lost tracking there. But eventually that deploy via ARM, as always, we'll draw ARM in. And what I would want to happen here as part of the pipeline, when I think about production deployment, there'd be multiple steps in that. So as part of this, it would be, well, one, use my infrastructure as code template to make sure the resources exist. Then I could push my sort of app code. And then I would do, hey, load testing. I might do some Chaos Studio to handle certain types of failures. I'm constantly validating. The whole point is I'm not waiting for some user to do things. I can build it into the pipeline so that it's just happening as a complete solution for me. So this is how all those things bring together. So a human is not deploying to production or anything else. I've, in advance, created my infrastructure as code templates. They're in the repo. They're part of it along with my application code. Hey, I hit a certain point, I do a certain trigger. Hey, I go and do these pipelines. And that goes through, and I automate as much as I can. There probably still will be human checks at certain points. Depends. But the better I can get the testing and the better I can automate that, I may not need as much human interaction as part of that. Ideally, humans are not part of it. I can respond to things a lot quicker if they're not. But if I'm taking humans out of the equation, I need to make sure I have really good gates, a good tests, good measures of, hey, is this working correctly? Is this successful as part of the overall process? Now, how do I do the pipelines? So GitHub, yes, is a repository, but it also has GitHub Actions. It has a whole bunch of other things. It's got fantastic security tools to convert my application to data so you can look for vulnerabilities. You can go and, hey, you've got a secret shared. But it has GitHub Actions that can drive those pipelines. Now, GitHub Actions can do a lot more than just CI/CD. I can create GitHub Actions, say, hey, someone has, I don't know, created a clone of my repo or started following something. So it really is about automation, which is why it's not just called DevOps or CI/CD. I can create actions which are steps on almost anything. So it's not limited to just triggers based on a commit. It's far more flexible than that. Obviously, I can use them to Azure. There are GitHub Azure Actions. we'll need to authenticate. There's different ways we can authenticate. The best way is using OpenID Connect. And what happens here is, rather than me having to store a secret somewhere, GitHub has an account and a certain repo and maybe a certain branch or a certain environment. And then in Azure AD, I create a service principal, but I associate it, which is now supported. I can create an external OpenID Connect connection to that GitHub particular branch or environment. And GitHub will give a token to my GitHub Actions workflow. And it says, hey, here's who I am. I'm from GitHub. Can you give me a token? And Azure AD will give me an Azure AD token exchanged for my GitHub token. So there's no secret anywhere. We'll see that in a second. I want to get the repo content locally, and then I can do stuff. I can go and deploy the template and do as many other things as I want. So if I was to super quickly, actually, we can maybe show a couple of things. So firstly, during that authentication, it's kind of cool. So if I was to look at my app registrations, is, hey, I'm creating a service principal. I created one called GitHub DevOps. And instead of having secrets, what I defined was a federated credential. And that is for John the Brit account, DevOps Masterclass, repository, and my test environment. Now I could also use branches. There's different ways I could do it, but that's the link I did. And then if I actually go to my DevOps Masterclass repository, if I go to Actions, I can see I've got a number of different workflows defined. But one of them is deploy my Bicep demo. Now, as part of the Bicep demo, if we look at this one, we can see the YAML file. So the YAML file is the definition of this. What I can see is, well, I have an ID token. I tell it where I want it to run on. So I'm running on an Ubuntu agent, and I'm using the test environment. So environments in GitHub Actions let me define maybe different sets of variables. So again, I might use different credentials, different naming for different things if it's test versus production. I obviously have to check out the content of the repo to this local agent, because obviously we need the code. So I'm checking out the repo so I have a full copy. And then I'm logging into Azure. And all I'm having here is the client ID, which is the ID of the app registration, my Azure AD tenant, and my Azure subscription. That's it. There is no secret stored. There is no anything else. And then all I do is, in this case, I'm deploying a Bicep file. I'm deploying to a resource group called RG policy test, and I'm deploying creating a storage account. And I ran this. We can run it again. But if I view the runs of this, firstly, I could just hit run workflow, and we'll run it now. This is one I ran, was it 3 days ago, just in preparation, obviously, for this course. But here I can see it running. I can see the actual jobs that make it up. So it's going to go and get a runner. So it's setting it up. So it's going to go and check out the repo. So now it's got a complete copy of it locally. Now it's going to do the login. It's the login I care about for this example, because what we'll see it doing is it's using that OpenID Connect. So there is no secret or certificate I had to store. But what you can see here is I used the OpenID Connect authentication. So I can see the issuer of the initial token was GitHub user content token. And then what it did is it exchanged it for an Azure AD token. And then it's using the Azure AD token to then actually go and connect, authenticate to Azure. And then it's doing this Bicep deployment file. And all this Bicep deployment file does is, if we go and look at another resource group, I think it's RG policy test, I said. So we just type in policy. There you go. I already ran it. Again, I have to leave them running now because otherwise people will steal my storage account names. But it's just deploying this. And it would just, it exists already, but it will say, hey, this resource exists, probably nothing more for me to do. But it's creating that deployment. And then there's some cleanup tasks. So that completed successfully. Notice, even if it already existed, it didn't error. I didn't say, hey, this exists already, failure, failure, failure. It doesn't care. It's idempotent. I can run it as many times as I want. So as the start of my pipeline, I would always have that idea of, well, run the infrastructure as code to make sure those resources do exist and they match my configuration. If they already exist, fantastic. But there's no harm done to it. But it will now make sure it matches the resources I need, then deploy my app code on top of it. So that's how we're bringing all of these things together. Our infrastructure as code becomes an integral part of the pipeline to make sure the resources are there into which we deploy our images if it's containers, or our binaries if it's something else, whatever that may be. But it's part of the all-up solution. So that was it. That was our infrastructure as code and DevOps module. Many different tools we have available. Yes, the pull tool is great, but it's not scalable. There's no way to guarantee consistency because it's the human mashing at the buttons. PowerShell Azure CLI are great scripting command line interfaces. They're great for automation. I still don't want to use them for provisioning because if it fails, if I want to change something, it's not going to work the same way. I have to do different commands to change than to create. But templates, be it JSON or Bicep or Terraform, I'm describing what I want the end state to be, not how to do it. And it's idempotent. I can run it as many times as I want. It doesn't matter. It will make it so. The great thing about those then is I can use version control to track the changes to my infrastructure as code or my app source code, whatever that might be. Hopefully not your configuration files with secrets in. We never put secrets in a version control system. They should be in a key vault. We should use managed identities so we avoid them altogether. Never put secrets or access keys in version control. Once I've got it, I could have a central repository where I can then collaborate with others. When I do certain types of actions, I might want to trigger an actual deployment to a test, to a production, and that all comes together with my pipelines. So that was it. I hope that was useful. I hope you learned something. And as always, till next video, take care.